Hi everyone, we are the team Placebo Detectors, and our project is called Heart Attack Data Analysis. So for today's presentation, we will have overview, EDA, machine learning models, conclusion, our team, those five parts. Now I will let my students go through all of them and introduce the whole project to you. So Himani, you can be the first.
So we collected our data set from Kaggle, and it predicts whether or not certain individuals had a heart attack through focusing on varying health conditions that these subjects have. This data set contains 14 different variables such as age, sex, resting blood sugar, and maximum heart rate achieved. And if you click on our data set, you're going to see that there's 14 columns and more than 300 rows right here.
Yeah, this is Kaggle's page of our data set.
And we also created multiple visual models to help predict the chance of having a heart attack. I'm going to pass it to Humza to talk about the EDA.
So this is so we're gonna go over our exploratory data analysis, and over here is just an example of our data set. And as you can see, there are 14 different columns, including output, and basically the columns represent different, I guess, biometric data about the person. For example, you can see there's an age column, a sex column, a chest pain type column, the person's resting blood pressure, the person's cholesterol measurement in um, micrograms per deciliter, and so on. And basically what happens is the output column just shows the chance of the person having a heart attack. One is means that there's a greater chance of having a heart attack, and zero, it means that there's a less chance of having a heart attack. And here's our correlation heat map. So first we created a correlation table to show how different medical metrics correlated with the heart attack risk of a person, and just how they relate to with each other. And as you can see over here, there isn't much correlation in between the variables, as most of them have a correlation of under 0.1. And I'm gonna pass it over to Caroline so she can explain the different data visualizations we use.
We made graphs for the variables age and sex to see how much they affected the chance for someone to have a heart attack and see which type of people had the highest risk. This is the graph for risk based on sex. It shows that the chances are similar for both males and females, but males have the highest probability overall. This is the graph for risk based on age. As you can see from this histogram, there's a peak from the ages 41 to 45, and the ages 51 to 54. Graph also shows that people below the age of 40 and above the age of 70 have a lower chance. Because of this, the ones who have the highest risk are people from the ages 40 to 60. And they should be more careful to regularly check for the warning signs of a heart attack. I'll pass it to Anya.
We integrated several machine learning models in our project, as machine learning is an important aspect of our project that allows users to submit their data into our program and analyzes it to make decisions based on input data. By examining variables such as age and sex, our models can predict the chances of a possible heart attack. We also used a confusion matrix after all of our models to show us how well our model is performing, what kinds of errors are being made, and an overall overview of what we need to change to make our model as efficient as possible. So we used 4 kinds of classification models. I will be talking about the first 2, which are the KNN models and the SVM models. The KNN model is a supervised learning model that uses distance between neighbors around a point to check how similar they are and classify the point. The K is the amount of surrounding points that will be considered to classify a point. In our KNN model, we created a for loop to find the optimal K value that gives us the best accuracy for classifying whether someone will experience a heart attack or not. When we plugged in one of our optimal K values, we got an accuracy of 88.5% and a recall value of 0.89. As you can see in our graph, in our confusion matrix, the number of true positives and true negatives are a lot higher than the number of false positives and false negatives. Moving on to our second model, the SVM model. The SVM model is a model that finds a hyperplane or divider in n-dimensional space that helps separate and distinctly classify points to separate the two classes of data. We needed help from the computer to choose a hyperplane that provides the best accuracy when classifying data points. So SVM models were a perfect fit for our classification application. As you can see in our confusion matrix, our true positives and true negatives are also a lot higher than our false positives and false negatives. In addition to this code, we also used a grid search to help tune our hyperparameters so we could find the best possible accuracy. And we ended up with an accuracy of 85.2%. I will be passing the next two models on to Keilani.
Okay, so we made a random forest model to measure how accurate it was when classifying whether a person will have a heart attack or not. And in the images, the visual graph displays a for loop code that helps tune the hyperparameters of n estimators and random state variables. And we also created two models of cross-validation, and they're called K-fold cross-validation and grid search cross-validation. The K-fold CV creates and tests training and testing models, while grid search finds the best parameters to use. And for each cross-validation model, we made confusion matrices to make sure our accuracies were consistent. And our last figure is the gradient boosting model. It predicts the best output value, which would be classifying a heart attack or not, and it minimizes errors made from past models. We provided images of an ROV curve and a precision recall curve, which both show the correlation between true and false positive rates. And similar to random forest, we also made a grid search model and confusion matrix to tune hyperparameters and help maintain a high consistent accuracy. And now I will pass it on to my teammate, Cecilia.
So in conclusion, we created this table that compares all the accuracy, recall, and precision values. And upon reviewing this, we decided that our random forest models would be the best as it yields the best accuracy for the predicting the likelihood of having a heart attack, comparing it to the rest of our models in general. This is mostly the reason why this model does so great is for the fact that it uses various decision trees that then collect samples of the data set, and each decision tree then averages them out to make a final prediction, resulting in its high accuracy. So the reason why our end result and this data set in general is so significant is because this project as a whole has made it possible for a person who would have never known that they had a heart attack be able to find out if they are in a higher risk than they thought. This will allow them to take more preventative measures, such as like going to the doctor or lowering their blood pressure or going on a diet, just to have a better, healthier lifestyle and avoid this. And it is plausible that in the long run, if our project was to be implemented, that this project could help even eliminate the possibility of someone having a heart attack long term.
Hey, thanks, Cecilia. So at the end of our presentation, please let me introduce my team and my students. We have Humza, Himani, Cecilia, Keilani, Caroline, Anya, and me as an instructor. So my students all did a good job, thanks to them. And thanks all for listening. That's all.